Okay, so today we're in Tesco on Aberdale Road. We're in the car park and we're looking at this structure here, this canopy which is used for the car wash here. And there's actually a couple of interesting features we're going to look at in terms of the structure of this canopy. First, you have this long span coming out from the column, and this is going to have to resist loads somehow, and we're going to see how it does that. But second, it's interesting to notice that this is actually a composite structure. So you've got the arch structure at the top, this comes down, it has to be transferred to those beams, and then finally to the column. And the whole structure is going to have to work together. So we're going to be looking at what sort of loads are going to be on this structure. Obviously you've got the self-weight of the structure, this is true for any structure at all you're going to find. But there's also might be some weight of things that fall on there. You've got some trees over there, the leaves or branches aren't going to be that significant, but you might get snow loads, and that might be something you're going to have to seriously consider as a designer. There's also the space under the canopy that might be affected by wind loads, and that could cause some uplift on these members we have here, which are going to have to be resisted, as well as the weight of the structure. But there's one thing we also need to consider, and that's we're in a car park, so some of the most critical loads might actually be in the rare cases where cars crash into the bottom of these columns. But that's something the designer is going to have to look out for and incorporate into their design. So there's a few different ways that we could design this column to resist the shock load of a car bashing into it. Now the first thing we could do is to put some restraints here at the base of the column. And we see we've got a little something. What we really need is a cage to stop any impact, absorb any impact from the shock of the car. And so this isn't really going to help us much. The other thing we could do is to design this canopy into the car park in such a way as to minimize the possible impact we're going to get. And you can see that this has kind of been done because this canopy is situated right in the corner of the car park. So the velocity of any cars coming that might potentially crash into it are going to be seriously minimized. And that's good, that's what we want. And the other thing we can do as a designer is to actually design the column itself to resist and absorb the impact. And we do that by, first we'll have a design code which will state how much of the height of the column is going to be utilized to resist the force, and then we have to work out the force itself. And we use Newton's second law to do this, F equals ma. So we've got the mass of the car, and then we've also got the acceleration as it stops as it hits the column. We work this out because acceleration is the first differential with velocity, so energy equals mv squared over 2. And then incorporating, obviously there's going to be some absorption as the column deflects. We can use that to calculate what force the car is actually going to exert on the column and design against it.